Okay, hi. So I'm assuming by now you understand the different features of waves, and now we're going to have a look a bit more in detail about the properties of waves and how they can actually interact with different things. Now, the first one is something known as reflection. Now, you all know what reflection is in real life terms because everyone has had a look in a mirror at some point, and your reflection, which is looking back at you, is a result of visible light being reflected. Now, the first thing I'm going to do, which a lot of students find really confusing, is simplify something. So, we saw in the last video that waves can look something like this. So this is, of course, not even at all, but they go up and down, and this is what the wave looks like, and the wave may be moving in this direction. Now, what we're going to do is if, let's say, for example, let's just use white here. If we were looking above here, so this is our eyeball, okay? If we're looking down onto the top of this, we couldn't see any difference in the peaks and the troughs because it'd all just be a straight line. And so that is what I'm going to call a ray. And so the ray of this is if we look from the top down, so this way, it's going to look just like a straight line. Just like a straight line like that. If I then came round and looked from the side on, so I have my eyeball here and I look from the side on, this way, then I would see this on the left hand side. But from the top, you can't see the difference. Okay? Now, this is what we are going to use in diagrams because it makes things a lot easier if you don't have all these squiggly lines everywhere. But a lot of people have a look at the straight lines you see in the diagrams and they think, well, how do we get from these squiggly lines to the straight lines? And that's something I don't think is explained often enough. So this is what we're going to call our ray. Okay? And so whatever our wave is, whether it's light or whether it's even sound or whatever, we're going to have a ray, okay? Now, let's move down a little bit. What we're going to have a look at is, of course, a mirror. So, let's draw one of those in. Let's just say that this line here, this here is a mirror. Now, the first thing we're always going to draw in is this imaginary line, which is the normal to the surface. And by normal, so let's write normal here. By normal, we mean that it is perpendicular to the surface. So the mirror here is vertical, and the normal is going to be completely horizontal, so 90 degrees to the mirror. If the mirror, for example, was like that, then the normal would be perpendicular at 90 degrees, okay? Let's just get rid of those. Now, what we have coming in are, we have one ray coming in, and we'll have one ray going back out. And these are called the incident rays and the reflected rays, okay? Now, one example would be the incident ray coming in at exactly the normal. So like so, this is the incident ray. Now, the reflected ray is going to come straight back at exactly the same angle like that. Now, this is a special case, because we haven't had a change in direction. We've just had it go straight back, and so it's gone exactly the opposite way. So we haven't had a change in angle. Right, let's get rid of those. The rule is that the angle that the incident ray makes with the normal is going to be equal to the angle that the reflected ray makes to the normal. So if we have a beam of light coming in from here, maybe you've got a laser pen and you've shot that light in here, it is going to be reflected at exactly the same angle. So let's draw that angle in. The angle here, we give the letter I. That is the angle of incidence. And incidence, because it is the incident ray. So this is the incident ray. Now this here is going to be our angle of reflection. So that is given the letter R. Angle of reflection. Sorry about the handwriting. And that is because this here is the reflected ray. Okay, and so the law is with reflection off a smooth surface, so this is a smooth mirror, that's the angle of incidence is equal to the angle of reflection. And that angle is the angle that it makes with the normal, not with the mirror. And so if you think back to the straight line example coming exactly on the normal, well, there is a 0 angle with the normal, and so the reflected angle is going to be 0 as well, so it's going to go straight back. Now it's important to note that this rule only stands firm if we are talking about a smooth, flat mirror, and we call that a plane mirror. Plane like that, not plain as in plain boring, plane as in like an aeroplane, so plane mirror. Okay, now when we are using light and we can see a reflection, it's important to note that what we are forming is an image. So we are forming an image. Now this image is a virtual image. Virtual. And what virtual means is that it cannot be projected onto a screen. This is in contrast to a real image, and that's because in a real image the light rays are focused onto a screen. So if you put a screen in front of your mirror, the screen wouldn't have just a representation of you on it. It wouldn't show an image of you. Whereas if you had a photo of you and you put it into a projector, that would shoot the light rays which make up an image of you. So that would be a real image. Virtual image is the one that we can see, but we can't put it on a screen. The light rays are focused on screen to make a real image. Okay. Now, finally, when we are producing an image from a mirror, or a plane mirror, we get an image which is virtual, as we've already mentioned. It is upright because when you see a reflection of yourself, you're not upside down, but it is laterally inverted. Laterally inverted. And the reason for that is that the ray coming in is going in one direction, the ray going out, if you have a look, is going in the opposite direction. Even though it's coming from the same way, it's changed direction. And so if you're standing in front of a mirror, if you raise your right hand, it looks like in the mirror you raise your left hand. That's because it's opposite to your right hand. If you're standing in front of someone, they're almost like a mirror image of you, but their left is on the same side as your right. So that's exactly what a mirror is doing. Okay, so the image is laterally inverted, but it is upright. And of course, it's a virtual image. Okay, so I'm going to stop there. That was just a brief overview. Make sure that you can remember that the angle of incidence equals the angle of reflection for a plane mirror. In this course, you will only ever be asked about a plane mirror, so that is fine. And it is a virtual image which is upright and laterally inverted. Now, if you do have any questions on what we've covered today, then please feel free to give me an email using the link below, or post a comment and I'll be sure to get back to you. But I look forward to seeing you in the next video.